Hello, I'm Paul Beckwith. I'm in my comfortable office at the University of Ottawa. I often teach both at the University of Ottawa and also at Carleton University in the departments of geography. Teach courses like oceanography, climatology, meteorology, environmental issues, different geography courses. I'm going to chat with you today about the state of our planet, about where we are now, where we've been in the past, and where we're heading. As people go about their very busy lives, both, in the real world and in the online digital world, we seem to have less and less time to think deeply about various subjects. There's a lot of um, shallowness, there's a lot of distractions. Our minds are constantly pulled from one thing to another, and often, we can't really have the wisdom or the luxury of thinking too deeply about things, right? So as we go about our lives and our jobs and, earn a living to put food on the table, support our families, have a roof over our heads, it's very easy to sort of lose track of what's happening around us. So I'd like you to have sort of think about things, around you in the past, and think about what things you see now, and, where things are heading in the future. For example, just simple things like the number of insects. You drive on a country road, just a few years ago, the windshields would be plastered um, with bugs, on the headlights, on the windshields, right? It would be a mess. And now, often, as I drive through rural areas, there's absolutely nothing on the car. So, why, for example, is this happening? And how does this affect the ecology of different ecosystems? Like, what eats the bugs? Birds, for example. How does it affect bird numbers? Right? Like, there's connections between everything. So try to think of some of these connections. So let me tell you what's going on with the climate. Okay, there's no normal. First of all, you might hear that the new normal is more extreme weather events, more tropical storms like hurricanes, things like that. Maybe torrential rain events happening more often, droughts happening more often, things like that. And you might think, okay, well, this is the new normal. We just have to adapt to this. But there is no new normal, because what we're experiencing and living through and undergoing is abrupt climate change. So what I mean by abrupt climate change is, the climate change has changed slowly, and then we're undergoing this abrupt ramping up, a very rapid acceleration of all different things on the planet. Very, very quick changes as we head to another state which is much warmer than the existing state. So there's no new normal, really. The changes are being magnified and increasing around the planet at an ever faster rate, and we're heading into really new territory. So let me explain a little bit about why. Okay, if this is the Earth and these are the poles, the sun is coming in and it warms the surface of the Earth, and we've changed the chemistry of the gases that surround us in the atmosphere. We've changed the chemistry, we've changed the concentrations of greenhouse gases, and these gases are trapping heat. So the more greenhouse gases there are, the more heat that is trapped, the Earth is warming up. But the equator, we know the equator is very warm and the poles are very cold, and heat tries to move from the warm areas to the cold areas, and it does this in the atmosphere, basically in the wind patterns, the air circulation patterns, which forms the jet streams, which circumvent the globe. About 2/3 of the heat is transferred in the atmosphere, and about 1/3 of the heat tries to move from the equator to the poles in the oceans and sets up things like the Gulf Stream, etc. But the Arctic we're used to a cap of a white cap at the poles in both the Arctic and Antarctic. And that white cap is the snow and ice. So it's the ice covering the Arctic Ocean, and it's the snow on the land, and also that covers the sea ice. And what's happening is because of this warming, we're getting a lot of melting, exponential decline of the area of the sea ice and the area of the snow cover on the land. So the Arctic is becoming a lot darker. So it's absorbing more of that sunlight, it's heating up, and then there's less ice, and then it's heating up even more, and there's less ice, and we get a vicious feedback occurring. So we get this Arctic temperature amplification where very far northern parts of the Arctic are warming at 5 to 8 times the rate that the rest of the planet is warming at. And this is very important because this temperature, cold Arctic, warm equator, that temperature difference sets up the jet streams which circumvent the planet. The jet streams are slowing down because the Arctic is warming, so that reduces the temperature difference to the equator. So the jet streams are slowing down and becoming wavier and becoming stuck. So we're seeing a rapid increase in extreme weather events. For example, torrential rains leading to droughts, or torrential rains leading to floods, or droughts in other regions because the clouds don't get there, so the rain doesn't fall in those regions. The storm patterns are guided by the jet streams. The jet streams are slowing down. The storm patterns are slowing down. We're in a warmer planet. For every degree Celsius or increase in temperature, that's 1.8 degree Fahrenheit increase in temperature. There's about 7% more water vapor in the atmosphere. There's more water vapor, therefore there's more energy in the atmosphere, and the storms are more intense. So we're getting extreme weather events happening more frequently. They're much more severe, and the duration is much longer because the storms are moving more slowly across the planet. Okay, so where is this taking us, and how will this affect humanity, civilization? Well, we're seeing a lot of the consequences of these extreme weather events already. We've only had, just over a degree of warming, 1.2 degrees or so, relative to pre-industrial. We're setting record temperatures month to month and year to year. There's some variability, but we're basically accelerating to a much warmer world as we transition through this abrupt climate change. So how is this going to affect us? Well, we're seeing all of these different effects on infrastructure. We've had a very bad couple of months with all of these massive storms. If you look on a global basis, there hasn't been, the last couple of months, there's just nothing unusual about it compared to what we've been seeing, say, over the last 5 years or so, in terms of the extreme weather events. What we are seeing, what is different, is these events are impacting the U.S. Disproportionately. So people, in the West are noticing, people in developed countries are noticing, first world countries are noticing that things are going haywire with the weather. So just look at the storms, for example, Harvey, so the superstorms, the hurricanes, the tropics, the seawater is very, very warm, much warmer than normal. So we're getting a lot of evaporation. We're getting a lot of hurricanes, tropical storms forming, leading to hurricanes, and we've had tremendous numbers of Category 5 hurricanes. And the jet streams are different. They're moving more slowly. So we had Harvey come ashore and linger over Texas and flooded out Houston. Then we had Irma come through, wreaking tremendous damage to the Caribbean islands and coming through to Florida. Then we had Maria, and there was Jose, which stayed offshore. And right now we have Ophelia, which is heading over to Europe. It's heading across warm water, and it could hit Ireland or parts of the UK, as a hurricane, or at least a very, very strong tropical storm. We're also seeing tremendous ramping up of megafires. Okay, the There's areas, we had lots of rain in California, for example. It caused a lot of growth of grasslands and shrubs. And then we've had the droughts in the summer, very dry, and this stuff is like a tinderbox. And we've seen multiple fires that have been destroying thousands of homes in a matter of hours very recently. And these fires are still ongoing. We're in a warmer world, and it's drying out soils and drying out crops and things, and there's also the crops are being weakened, trees are being weakened by pests, etc., and the extremely dry and hot temperatures, and they're burning. And this is a double whammy because this is a very strong, powerful carbon sink. Vegetation absorbing the CO2 as part of photosynthesis. And so as we get these large burn events, these large megafires, we lose that sink, and all that carbon goes back up into the atmosphere. So according to the International Energy Agency, we had basically a pause in human emissions over the last few years. But the amount what's really important is the concentration of these gases in the atmosphere, and that's still skyrocketing up at an exponential rate. In fact, we're still setting records, over 3 parts per million rise in CO2 the last few years, and I expect that this is not going to be a pretty picture because, the next data that comes out on the CO2 level, I expect to see a large ramping up of the concentration in the atmosphere because of all of the reduction of the sink capacity to pull CO2 out of the atmosphere from the vegetation, and also the CO2 that's added from all of these fires. So what do we do about this? Well, I think it's very clear what we have to do. We have to declare a global climate change emergency. I've done many videos on this, and what can I say? I mean, things are deteriorating very quickly. We need to declare a global climate change emergency. And then what do? Well, we need to slash fossil fuel emissions. I mean, countries are only doing half-hearted attempts right now. They talk about carbon taxes, they talk about carbon fee and dividends, or cap and trade. Meanwhile, follow the money. They're obviously not serious because they still have these enormous subsidies. Globally, there's 5 trillion. There's just incredible $5 billion worth of subsidies globally per year on fossil fuels. Actually, it's 5 trillion. Sorry, not 5 billion. 5 trillion. Canada alone, it's like 3.3 billion. It's just huge amounts of subsidies. We've got to get rid of these subsidies, and then when governments do this, then we'll know that they're starting to get serious about addressing climate change. But this is not sufficient. We've set this beast in motion, this abrupt climate change beast in motion. There's no new normal. Things are deteriorating quickly. It will hit our food supply and cause global food shortages very soon. Apart from all of the damage it's doing to infrastructure and all of the people that it's killing, etc. So we need to deploy climate restoration techniques. Talking about carbon dioxide removal, CDR, we need to develop and deploy technologies that will remove carbon dioxide from the atmosphere and get us down below this level of 410 parts per million, which we're knocking against, down to 350, 300 even. And we need to do this on an emergency basis. But this is still not sufficient because we're going to lose the Arctic sea ice and snow cover, have a blue ocean event, and extreme weather events are going to ramp up and get far more severe than they are. So we need to deploy solar radiation techniques. CDR, carbon dioxide removal, and solar radiation management techniques to, for example, put sulfur dioxide in the atmosphere or calcium carbonates in the atmosphere to reduce the levels of sunlight. And we have to try to keep the sea ice and snow cover in the Arctic, or we risk methane, huge amounts of methane coming up. So we have to do this. We have no choice. Thank you.